In this video, we're going to do another set of problems where we get to practice stoichiometry. This is set number 4. So this question says solid iron 3 oxide and aluminum metal react to form iron metal and solid aluminum oxide. So to write the balanced chemical equation, we need to be able to generate the formulas from the names of the compounds. So iron is Fe, oxide is referring to oxygen, that's O, aluminum is Al. Now, iron 3 oxide, that Roman numeral is telling you the charge of the iron. So that tells us the iron has a 3 plus charge. Positive because it's a metal and metals lose electrons and they're positive. Oxygen is traditionally always -2. So to make a neutral compound from iron 3 and oxygen 2 minus, you would need 2 irons and 3 oxygens. So Fe2O3, and it said it's solid, so I'll go ahead and write that the physical state is a solid. And then the other reactant, it says aluminum metal, so that's implying that it's just neutral aluminum, so it's aluminum that's not in a compound. So we'll just write Al, and metal also implies that it's in the solid state. And then we see the word react, so we can put the reaction arrow. And for our products, it says iron metal. So again, iron is Fe. Metal implies that it's just natural iron in the solid state. It's not in a compound, so it's neutral. So we'll just write Fe solid. And then solid aluminum oxide. So aluminum, let's look over the periodic table. There's no Roman numeral in that name, and aluminum is right here. It is always a 3 plus ion. It has 3 valence electrons, and it likes to lose all 3 of those. So aluminum in aluminum oxide is Al3 plus, and the oxygen is a 2 minus, of course. So to make a compound with aluminum and oxide, you would need 2 aluminum and 3 oxygens, so Al2O3, and the word solid is there, so I'll label it a solid. Now we need to balance it. So that's our chemical reaction, but we need to balance it. So let's go ahead and do this column approach. So we have iron, oxygen, and aluminum in this chemical reaction. On the left side, I have 2 iron. On the right side, I have 1. For oxygens, I have 3 on each side. And for aluminum, I have 1 on the left and 2 on the right. So to balance this, one thing we could do for the iron is we could put a 2 right here. And for the aluminum, we could put a 2 over here. So that brings us to 2 there and 2 there, and now it's balanced. All right, and again, you need the balanced chemical reaction to do stoichiometry, because in all of these examples that we're going to go through, we need to know what the mole to mole ratio is, so we can convert from moles of one substance to moles of another. Okay, so the first question, it says, how many grams of iron 3 oxide will be needed to react in order to form 15 grams of iron? So the 15 grams of iron, that's going to be our starting point, 15.0 grams of Fe, and our general plan is to go from grams of iron to moles of iron, and then to moles of aluminum. I'm sorry, we're going to iron 3 oxide, Fe2O3, and then since they're asking for grams of iron 3 oxide, the last conversion is going from moles to grams. All right, so we're going to start off with the 15 grams of iron, and we'll need 3 conversions, which is why I have the 3 arrows there. So first conversion takes us from grams to moles. It's a molar mass that allows us to do that. So we would need the molar mass of iron. So just looking over at the periodic table, iron is right here. It says 55.85. And since we want the grams to cancel, we put that on the bottom. So it's 55.85 grams per 1 mole of iron. Next, the second conversion, we want to go from moles of iron to moles of iron oxide. And to do that, we look at the balanced chemical equation. So we have iron had a 2 in front, and the iron oxide, we didn't put a number there, which means it's just a 1 in front. So for every 2 moles of iron that are produced, 1 mole of iron oxide is needed. And then the last conversion, to go from moles of iron oxide to grams of iron oxide, we need the molar mass of iron oxide. So just kind of a refresher on how to do molar mass. So Fe2O3. Fe2O3. So we need the molar mass for iron. So it's 55.85 times 2, since there's 2 in the formula. And then O3, so your molar mass of oxygen is over here. So you'd have 16 times 3. And then you would, do that math, add them together, and you should get 159.69. So I'm just going to fill in my units really quick. We need moles of iron oxide to cancel, and we want grams of iron oxide. And the molar mass that we should get is 159.69 grams per 1 mole. So that's our setup, and just confirming that our units are canceling appropriately. So grams of iron cancels with the first conversion, moles of iron cancels here, and then moles of iron oxide will cancel, and we will be left with grams of Fe2O3. So on your calculator, you're doing 15 divided by 55.85 divided by 2 multiplied by 159.69. And my calculator told me 21.44449, and rounding, sig figs. Okay, I'm going to consider sig figs just as a good review. So 15.0, that has 3 sig figs. So we want to round that 21.44449 down to just 3 sig figs. So, and I think I'm going to double check this, because on my notes I wrote 21, and then I wrote 12. So I'm just going to double check one more time on my calculator. 15 divided by 55.85 divided by 2 times 159.69. Yeah, it is 21. 21.4 for 3 sig figs. All right, next one. It says how many grams of aluminum will be needed to react in order to form 15 grams of iron. So we'll start with the 15 grams of iron again. And just like with the last one, we're starting from grams of one thing, and we're trying to get to grams of another thing. So there's going to be 3 conversions necessary. Grams of iron to moles of iron, then to moles of aluminum, and then to grams of aluminum. So we kind of start off with the same procedure. We'll have 15 grams of iron, and to convert to moles of iron, we'll use the molar mass, just like before, 55.85 grams of iron per mole. But then the second conversion, since we're going from iron to aluminum, we need to figure out, okay, what's the molar ratio going from iron to aluminum? They both have a 2 in front, so this will be for every 2 moles of iron that are formed, 2 moles of aluminum are required. And then the last conversion, to go from moles of aluminum to grams of aluminum, we need the molar mass. So on the bottom, we'll have 1 mole of aluminum, and then grams of aluminum goes up top, but we need to look at the periodic table. So scrolling over here, here's aluminum. It says 26.98. So 26.98 grams of aluminum goes there. So just checking our units. So grams of iron cancels, and then moles of iron cancels, and moles of aluminum cancels. So our units are good. We will end up with grams of aluminum, which is what they asked for. So in your calculator, you're doing 15 divided by 55.85. Times 2 divided by 2 is just 1, so you can skip that, times 26.98. And my calculator told me 7.2462. And since the 15.0 had 3 sig figs, we will round that down to 3 sig figs. So 7.25. All right, next one. It says how many grams of aluminum oxide will be formed if 1.63 times 10 to the 23 atoms of iron are formed? So a little bit different this time. We're starting with atoms of iron, and we need to convert to grams of aluminum oxide. It's still going to be 3 conversions necessary. They'll just be a little bit different. So our game plan is we're going from atoms of iron to moles of iron to moles of the aluminum oxide, and then finally to grams of aluminum oxide, because that's what they asked for. They asked for grams. So starting off with 1.63 times 10 to the 23 atoms of iron. Now, to do this first conversion, we use Avogadro's number, which is how many atoms or molecules or things are in 1 mole. So we're basically converting from atoms of iron to moles of iron, and Avogadro's number is 6.022 times 10 to the 23rd. There's 6.022 times 10 to the 23rd things in 1 mole, atoms of iron in this case. Okay, so then next we need to go from moles of iron to moles of aluminum oxide. So for our units, we have moles of Fe on the bottom and moles of Al2O3 on the top. So we need the mole to mole ratio. So looking up at our balanced chemical equation, we had, where is it? There it is. For every 2 moles of iron that are produced, 1 mole of aluminum oxide is produced. So it's a 2-to-1 ratio. So 2 and then a 1. And then for the last conversion, we want to go from moles of, let me write that a little bit better, aluminum oxide to grams of aluminum oxide. So we're going to need the molar mass of aluminum oxide, and we haven't calculated that yet with these problems. So aluminum oxide, Al2O3. So going over to the periodic table, Al2O3. So aluminum, 26.98 times 2, since there's 2 of them in the formula, and then 16 for oxygen times 3, since there's 3 in the formula. So you do that math, add them together, and you should get 101.96. 101.96. So that's our setup. Okay, now just checking for units canceling. So atoms of iron cancels when we use Avogadro's number, and then moles of iron cancels when we use the mole to mole ratio, and then moles of aluminum oxide cancels when we use the molar mass. So we end up with grams of aluminum oxide. Now, in terms of how you do this on your calculator, because once you get scientific notation over here, it can be a little bit tricky, especially if you're working on your phone or if you're working on a scientific calculator. So a strategy that you can do is just do the numbers in front. So like the 1.63 divided by 6.022 divided by 2 and then times 101.96, and then consider the times 10 to the 23 parts after that. And in fact, since they're both 10 to the 23, they're going to cancel anyway. But if we do that, so just the 1.63 divided by 6.022 divided by 2 and times 101.96, your calculator should tell you 13.7989. And then if you consider the times 10 to the 23 that showed up 2 times, then it's kind of like you've got times 10 to the 23 divided by 10 to the 23. So those are going to cancel. So anyway, you just got 13.7989, which we do want to round it to 3 sig figs, because 1.63 has 3 sig figs. So we'll just do 13.8. 13.8 grams of aluminum oxide. Okay, last one. This one's gonna have a few more steps in it, because they're saying if 10 kilograms of iron 3 oxide are to be reacted, how many kilograms of aluminum? So this one technically has 5 conversions, although 2 of them kind of knock each other out, and we'll see how that works once we set it up. So our strategy is to go from kilograms of iron 3 oxide to grams of iron 3 oxide to moles of iron 3 oxide. We have to get to moles if we want to use the mole to mole ratio. Then we would go to moles of aluminum, and then we would go to grams of aluminum, and then finally to kilograms of aluminum, since that's what they're asking for. Now the first conversion and the last conversion, just to kind of give a hint, those are going to kind of cancel each other out, and I'll show you once we get it all set up. But let's just start off with 10.00 kilograms of iron 3 oxide. So the first conversion, we got to go from kilograms to grams. So I put the kilograms on the bottom since we want kilograms to cancel, and grams on top. And you should strive to memorize, if you haven't already, that kilo is 1,000. So 1 kilogram is 1,000 grams. So I'll put 1 kilogram on the bottom and 1,000 grams on top. Okay, next we want to go from grams to moles. So on the bottom, I'll have grams of iron oxide, and in the top, 1 mole of iron oxide. So we need the molar mass of iron oxide, and I think we've calculated that once before already. So I'm just checking. Yes, 159.69. We used it up here. 159.69. 159.69. Okay, so the next conversion, we have to go from moles of iron oxide to moles of aluminum. So again, we'll use the mole to mole ratio. So moles of iron oxide, moles of aluminum. Okay, so scrolling up, balanced chemical equation. For every 1 mole of iron oxide that reacts, 2 moles of aluminum are also required. So we got a 2 there and a 1 there. Okay, next we have moles of aluminum. We have to go to grams of aluminum. So that means we need the molar mass of aluminum. So for every 1 mole of aluminum, and I think it was 26.98 grams of aluminum. That's the molar mass. And then the last one, going from grams to kilograms, we're going to use that 1,001 thing again. So, but now I want grams to cancel, so I'm putting grams on the bottom, and we need to convert it to kilograms, so I put kilograms on the top. And there are 1,000 grams in a kilogram. And this should give us our unit, so let's just double check. So kilograms of iron oxide is going to cancel, and then grams will cancel, moles will cancel, moles of aluminum cancels, and then grams is converted to kilograms. So that gives us kilograms of aluminum. Now, in terms of what you put in your calculator, you're going to have 10 times 1,000 divided by that times 2 times that divided by 1,000. So this multiplied by 1,000 and divide by 1,000 are going to end up undoing each other on the calculator. So in terms of what you type into your calculator, you could skip these 2 steps. I'm not saying you should skip them when you write out your work, but when you're typing them into the calculator, you could literally just skip them because they're just kind of going to cancel each other out. So I'm going to type in 10 divided by 159.69 times 2 times 26.98. And when I do that, I get 3.3790. And since this 10 that we started with has 4 sig figs, so all of those zeros count because that decimal is there, we want to round our answer to 4 sig figs, so I'm going to round it to 3.379 kilograms of aluminum. And that's it.